Today we are going to start taking a look at trigonometry. So it's going to be the last topic that kind of covers everything we do from now until the end of the year. And what I generally like to do first is just look at the word, break it down, and see if we can figure out some kind of meaning of that word based on prefix, suffix, anything like that. So looking at the word trigonometry, does anybody recognize anything in part of that word somewhere? Any part of it, yeah?
I see try is like kind of like 3.
Yep, try, so that does mean 3. Triangle, tricycle, having to do with 3. Anyone recognize anything else there? Yeah?
Metry, but like the end, would that be like measurement?
Yep, metry means measurement. So there's different subjects in math that end in metry. Geometry, trigonometry. Maybe that's it. But metry means measurement. And how about gone? Where do you see that? Yep.
Sided.
Yeah, it means like sided. You see hexagon, octagon, pentagon, decagon. The prefix tells you how many sides, and then gone is the word for sided. So technically a trigon is another name for a triangle. Okay. Every polygon has a name that ends in gon. Trigon is triangle. Four-sided shape, we normally use quadrilateral, but you can call it a tetragon. A tetragon is a four-sided shape. And then after that, they pretty much stick with the shape ending in gon. Pentagon, hexagon, octagon, septagon, things like that. All right, so three-sided measurement. So a lot of what we do in trig is going to kind of boil down to measuring the lengths of the sides in a triangle. And not only the sides, but also the angles. All right, so drawing a triangle and measuring something about it. All right, let me show you kind of a quick example. We're not going to solve it today, but something you could use trig to do. So let's say you have a building over there, and you are standing there, and you measure how far away you are from the building. Okay, which, as long as the ground is level, that's usually pretty easy to do. If it's not, well, we have other things we can measure. But let's say you measure the distance between you and the building, and it's 200 feet from there to there. And you're trying to figure out the height of the building. Okay? Measuring the distance to a building, that can be usually pretty straightforward. But trying to get the height of the building, well, they might not let you on top of the roof to drop a tape measure down. Could be windy. So it's not always directly the easiest thing to measure. But we can indirectly measure it by making a triangle and using trig. Okay, the only thing that we would have to know is basically the angle from where we are standing to the top of the roof. And that you can measure with different instruments, whether you have like a transit or you have some kind of laser pointer with a sight on it. As long as you have something that when you start tilting it, it tells you the angle that it's tilting at. I mean, even your phone does that. If you get like a compass app, you can start to tilt it, and it'll tell you the angle that you're tilting it at. All right, so that angle it's not that hard to measure. So let's say this came out to 40 degrees. Knowing those two pieces of information, the angle to the top of the building and how far away you are, you can find the height of the building. And what it comes down to is solving this triangle in blue for the height. That's what you're really doing. You're finding the height of that blue triangle. And because it's a right triangle, that makes certain things a little bit easier. So we'll talk about different ways we can solve right triangles in February at some point. February or March. Okay, another example is, let's say you don't have a right triangle. Okay, so let's say that we've got 2 towers. Okay, these could be just like towers in a forest, just different points. And the towers see a fire somewhere in the distance. So maybe what they want to do is somehow figure out where that fire is so they could program like a drone or something to fly over it and drop water on it. So if it's a fire, you want it to be pretty accurate. You don't want to drop water over here when your fire is over there. So you got to figure out exactly where the fire is. Well, these two towers working together can do what's called triangulation. As long as two different observers can see the same thing, they can figure out exactly where it is, right? But you need two. If you're the only person that can see what you're trying to find, you can't do it. You need another person. I guess the only way you could do it is if you like drove to another spot. The problem with that is if the thing that you're trying to figure out where it is moving, it won't work, because by the time you drive to another spot, what you're looking at could have moved. So it would work if what you're looking at is staying still. But with two people, it's very easy. So the first thing you need, each person needs to tell you, or each person in their tower, wherever they are, they have to tell you the direction that they can see the fire in. And if you have a compass, it's very simple. You can just look at your compass, turn, look at the fire, and then look at which way your compass is pointing. So each tower can tell you exactly the direction they see the fire in. If only one tower could see the fire, they could give you the direction, but they wouldn't be able to tell you how far away it is. Like if they could just see smoke, they could say, well, maybe it's like 5 miles away, maybe it's 6 miles, maybe it's 8 miles. Well, if you're trying to drop water on a fire and you're like 5 miles off, I mean, unless it's a huge fire, but if it's not a huge fire and you're 5 miles off, that's a pretty big distance to miss with the water. So you need that second tower. The other thing you need to know is how far apart the two towers are. That's usually pretty easy. It's no more complicated than looking up the distance between two cities on a map. As long as you got a map and you got 2 points on it, you can look at the map and figure out how far apart they are. So that's pretty easy. So the information you would have is maybe these guys are 5 miles apart from here to here. You'd have a direction from each tower, like from a compass. So maybe this angle is like a 40 degree, and this angle, I don't know if it looks a little smaller. Maybe that's like a 30 degree. And you've got 3 pieces of information. That's all you need. 2 angles on a side. You can figure out anything you want to know now. You could find the length of each side. You could find this angle up at the top. And with all that, you can triangulate and get a coordinate on a map for exactly where it is. You can do the same thing with cell phone towers. Like if this red fire was somebody's phone, you can ping that person's phone, well, the cell phone tower can, and depending on like the signal strength and how long it takes the ping to go out to the phone and come back, they can figure out where somebody's phone is. And with cell phone towers, there's usually more than 2, so the more you have, the more accurate. If you only had 1 cell phone tower that could ping you, they wouldn't be able to figure out exactly where you are because there's not enough information there. You need a couple towers to make that work. But that's called triangulation. All right, so we'll talk more about that. A little bit harder because it's not a right triangle. There's no 90 in it. But as long as we know a little bit of trick, we can figure it out. Some other applications, like more ones that you might do like in a certain trade, you can use trig to make sure something is square. So like if you've got, you're building a house, you know, you got a foundation, keeps going, but you want to make sure that your foundation is exactly at a 90. What you could do is you could measure out 30 feet this way, you could measure out 40 feet that way, and then if you measure that diagonal, it should come out to 50 feet. It's basically a larger application of a 3, 4, 5 right triangle. So you can make sure that your foundation is square. Same thing in like a doorway. You can do the same kind of thing, 3 feet, 4 feet, measure the diagonal. There's also other ways you can check for squareness. You can measure diagonals, all kinds of tricks with triangles you can do in different trades. A lot of construction trades to figure things out.
Usually in house carp, we measure from corner to corner to check for square.
Yeah, like the diagonals?
Yep.
Yep. So yeah, you can definitely do that. And there's a reason why that works, having to do with triangles. Yeah, there's all kinds of different things with trig. So the nice thing about trig is it's more relatable to, I would say, different shops and trades a little bit more than some of the algebra stuff we did in the first part of the class. And we're going to do something today with triangles and measuring them, so it's exactly what trigonometry is all about, measuring triangles. All right, so let's take a look at our first section, which is 1.1, and it's on what we call the distance and midpoint formula, both of which have to do with triangles. Well, the distance formula definitely has to do with a triangle. Midpoint formula, not so much. All right, so what is the distance formula? Well, basically, it's if we want to find how far apart 2 points are on a grid, okay, on a coordinate plane. And why would you want to find out how far 2 points are? Well, again, maybe you're doing that map problem where you got the 2 towers in the forest, and they want to know how far apart the towers are. Well, if the towers are on an angle like that, and you put a grid in there, it's not going to be super easy to figure out the distance directly because you don't have a grid. Oh, it's probably putting it up at the top. You know what I can do? Let me do this. Let's just put this in, and just make it bigger. Okay, so now we got a grid. Let's put one corner of that right on there. So I want to figure out how long that bottom dotted line is. The problem is it's not straight, right? If it was straight, I could just count. 1, 2, 3, 4, 5, count how many blocks, right? But it's kind of at an angle. So I'm trying to find the distance from here to there. And what I'm going to do is let me erase some of this other stuff just so it doesn't look as busy. And you know what? Forget about those other 2 lines. We don't even need those. Move those off. All right, so just want to find out how long that line is. Okay, so forget it's a word problem about smoke and a fire and all that stuff. The first thing that we need in order to find the distance between those 2 points is the coordinates. Okay, that's pretty easy to get. Okay, I can see looking at my picture that I've got a coordinate, let's say right there, and another coordinate, I'm just rounding it off a little bit, right there. Okay, so now that I've got those 2 coordinates marked, I'm just going to move that out of the way. I don't even need that anymore. And I want to find the distance between those 2 dots. Well, let's call this point A. So this one will be point A, and that's point B. So what kind of distance would be easy to measure on that grid? Diagonal distance, not easy. But what other kind of distance would be a little bit easier to measure?
Horizontal and vertical.
Yes, horizontals and verticals are very easy to measure. So what we're going to do is, instead of measuring that distance directly, we're going to draw a shape. And we're going to measure something on that shape that's going to help us to get the diagonal. Does anyone have an idea what shape I'm going to make? And points A and B are going to be 2 of the points in the shape.
Triangle.
Yeah, we're going to make a triangle. And what we're going to do is draw a line on the bottom. Now the length of that side is easy to measure. I can just count whenever I'm ready how far over I go. And then the vertical, that's also easy to measure. Okay. So the vertical is just 1 unit. Now I want to find that. That green dotted line, it's the 3rd side in that triangle. but it has a special name because it's across from a 90-degree angle. Does anybody know what you call that green dotted line? The hypotenuse. That's how you find the distance between 2 points that are not lined up horizontally or vertically. You make a triangle out of it, and you find the length of the hypotenuse. Does anybody remember what formula, probably from geometry, you can use? If you know the bottom and the height, you can find the third side. Yep.
Pythagorean theorem.
Right, you can use the Pythagorean theorem. So that's exactly what we're going to do here. We're going to use Pythagorean theorem. We're just going to write it in terms of coordinates. All right, so let's write down these coordinates. This one is x1, y1. This one is x2, y2. And I know I could get the exact coordinate, but that's not important. If you wanted to find the black dotted line, that horizontal, the length of it, you would only need to use part of each coordinate. Which part of the coordinate would you use?
X.
You would use the x's. So if you have an x value here, and you have another x value over here, and you want to find the change between the two, the distance, what operation would you use in math to find the change between two x values?
Subtraction.
Yeah, you would use subtraction. If you took x2 and you subtracted x1, that would tell you how long it is from there to there. So x2 was like 7, and x1 was, I don't know, -5. If you did 7 minus -5, that would give you the distance between those 2 points. Right, so you find the difference between your two x's. And now we're going to do the same thing here. I want to find this. What part of the coordinate would you use to find the height?
Y.
You'd use the y's. We know that we have a y value here. We have another y value up there. That bottom one is at y1. The top one is at y2. Bottom one is y1. Top one is y2. How would I find the change between those? Or how would I find how far apart those two y values are? Yep.
y2 minus y1.
Yeah, we just subtract them. So if y2 is at 7 and y1 is at 6, if I subtract the 2, it'll tell me how far apart they are, which is the height of that triangle. So this side is y2 minus y1. All right. Now we just have to do the Pythagorean theorem. Can someone remind me what's the Pythagorean theorem? Yep.
A squared plus b squared equals c squared.
Okay. Now, since I don't have those letters on the board, can you explain to me what they are?
A would be x1 and y1. B would be x2 and y2. Oh wait.
Just in general, what is A, what does A mean?
Oh, A would be the base.
Yeah. What about the
The
base?
leg.
The leg, and it's the. What about the leg? The color of the leg?
The length.
The length of the leg. Yeah. So A is the length of one leg. What's B? Length of the other leg. And what's C?
The hypotenuse.
The length of the hypotenuse. Yep. So now just fill in for A and B, and you'll have the distance formula. Okay. So what's the length of the bottom leg?
13.
Well, in general, let's pretend we don't have pretend like you don't have a grid there and you can't see any coordinates.
x2 minus x1.
x2 minus x1. That's the length of the bottom. Squared. What's the height?
Y2 minus Y1.
y2 minus y1. And c, well, that's what we're trying to find. That's the distance between points A and B. So we could just put distance of segment AB. Move that down a little. You know what? I don't want you to think that's division. So I'm just going to write out the distance of segment AB all in words. Distance of segment AB. There you go. And that is the distance formula, which I think I had. Yep, right there. Now, generally what we're going to want to do is we're going to want to solve that formula so it doesn't have distance squared. We just want distance. So what would I have to do on each side to make this side just this? Just the distance.
Square root it.
Right, I'd have to take the square root on both sides. If you take the square root on both sides, that's going to get rid of the 2 on the right, and it's going to turn the left side into this. You can't simplify that anymore. These squares and square roots do not cancel out because there's too much other arithmetic happening there. All right. So that is the distance formula. X2 minus x1 squared plus y2 minus y1 squared. And then you take this, you add them up, take the square root. Okay, so it's all based off of a triangle. That's all it is. Triangle and Pythagorean theorem. All right, everybody have that formula? All right, so let's look at an example. So find the distance between the points 4, 5 and 3, 2. Okay, that's the same formula you had up above. Instead of writing the distance of segment, I just put distance from A to B. But that's the same formula we just wrote down. Okay, first thing I would do there is, if you're not sure which number is which, let's label each of those 4 numbers, and then we'll know where they go. Bless you. Okay, let's start with the 4. What, out of these values up here, what is the 4?
X1.
Yeah, that could be x1. And the 5 would have to be y1. And technically, you could make them x2 and y2. You just have to keep them with the same number. Okay. So x1, y1. How about the 3? Yes. It's going to be x2. And the 2? y2. Now it's just a matter of taking those 4 numbers and filling them in. And keep in mind, what you're really doing here is you're making a triangle. You're finding the length of the bottom. You're finding the height. You're squaring them, adding them together, and taking the square root. So you're really doing Pythagorean theorem. That's what this formula is. But we don't have to make the sketch. We're just going to fill in everything. Okay, so what I generally do is I do this first. Because there's a lot of symbols and different things happening, I write the formula down, and then I fill in. Okay, so first thing I fill in is x2. Next thing I'm going to fill in is x1. Then we fill in a y2, which is 2. Then we're going to fill in a y1, which is 5. Okay, let's see what we got. Okay, 3 minus 4 is going to give me how much? -1. And then when you square it, 1, plus 2 minus 5 is going to give me negative 3. And when you square negative 3, you get 9. So the only thing left is to simplify what's underneath. And that's the exact distance between the 2 points. Okay, square root of 10. If they don't specify how to leave your answer, you can just leave it as an exact. If they say round to 2 decimal places, well, you're going to do square root of 10. And that one would be about 3.16. Everybody know how I did the square root on there? Second square root? Okay. Any question on how we found the distance between those 2 points using the distance formula, which is really just based on a triangle and uses Pythagorean theorem. All right, so let's try this one. Something different is going to happen when you get to that step, and I think we've dealt with it before, but we'll talk about it. So let's label them, make sure we know what's going to go where. Felicity, what could I label the 2 as? I have 2 choices.
X1.
Could be x1 or what else could it? It could potentially be this too. Yeah. It could be x2. I mean, it's an x value. Which is it, x1 or x2? It doesn't really matter. But once we decide what it is, then everything else does matter. Okay, so I'm just going to go with the first thing you said, which is x1. And now there are no more choices. Okay. The 6 has to be what? It has to be y1. Nope. And the 4 will be, that's my x2, and y2. Okay, so let's set it up. Fill everything in. Let's see what we get. Okay. What are we going to fill in the left side of the first parenthesis?
X2, just
We're going to fill in x2, which is 4. And what are we going to fill in on the right side?
X1.
x1, okay, which is 2. All right, so we got that. How about, Dylan, what's going to get filled in on the left side of the second parenthesis?
That'd be 6.
So if we follow that, we're filling in y2,
Oh,
which
Y2.
is
Oh,
10. And then the last thing we put is the 6. Okay, so let's do this out. 4 minus 2 is going to give me 2. And then when we square it, 4. 10 minus 6, 4. And when you square it, 16. So we get the square root of 20. And at that step, we were done in the last problem. This time we are not done. Why not? Yeah.
Can we simplify?
Right, we have to simplify. Okay? Simplify doesn't mean round it off to a decimal. Simplify means to reduce it as an exact answer as much as you can. So there are different ways to simplify it. Some people do like a factor tree. I just break it up into 2 numbers that multiply to give me 20. And one of them has to be a number I can take the square root of in my head. So how can we break up 20 that way? Yeah.
4 and 5.
Yeah, we can break it up into 4 and 5. And the rule when you have a product like that under the square root, you take the square root of each number separate. So we've got square root of 4 times square root of 5. And the square root of 4 is going to reduce. What does the square root of 4 reduce to? 2. So we get 2 square roots of 5, and that's the exact answer. All right, so that's one of the reasons I start with distance formula when we do trig, is because it also reviews reducing square roots from algebra. It doesn't happen in every problem, but this time it did. If we want to double check our answer, type in square root of 20, see what you get, 4.47. Type in 2 square roots of 5, 4.47. Yep, we're good. Okay, so any question on that one? Again, I think we've had square roots we've probably had to simplify before now, but if not, that's how you do it. And here's some steps. If you don't know how to simplify the square root, you can write them down. If you have a method you already know how to do it, then that's fine. So the goal is to factor the number 20 so that it's something times something, but it has to be a number that's a perfect square. Writing 20 as 2 times 10 wouldn't help with my method. I think I have another one. Actually, we did square root of 20. We'll try another one of those in a minute. Okay, so break it up. And then once you break it up, take the square root of each number separately and go from there. Okay, anyone need to copy that? I can keep that up if people are copying it. All right, so we already did square root of 20, so I'm not going to do that one. Let's do, I think the next one was square root of 48. Yeah, let's try that one. So we're going to break it up. We want to break up 48 into something times something, preferably the biggest number you can think of. Right? If you don't use the biggest one, it's okay. We're just going to have to do this more than once. Can anybody think of what times what gives you 48? And again, I prefer the biggest perfect square you can think of. Yeah?
12 and 4.
Okay, we can do 12 and 4. We can start with that and see what happens. And what's the square root of 4? 2. Now, because 4 wasn't the biggest perfect square that goes into 48, you end up with something that needs to be reduced again. Okay. So now let's reduce 12. How can we break up 12? So it's a product of 2 numbers, and one of them is a perfect square.
4 times 3.
Yep, we can do 4 times 3. Now simplify what you have in front. What's the square root of 4?
2.
2 times another 2.
4.
4. That is as simplified as you can get. Does anybody see how we could have done this one differently from the beginning and avoid having to do it twice? Does anybody see a bigger number that goes into 48 that we can take the square root of?
16 and 3.
16 and 3. Yep. 16 times 3 is 48. And what's the square root of 16?
4.
4. Yep. I don't know why my 3s are doing that. It's kind of weird. But you end up with the same result. Okay. The method on the left, that's generally good if you have a really big number and you're just struggling with it. At least if you find some number that works, you'll reduce the problem and make your number smaller. Might not be the final answer, but at least it gets a little smaller. All right. Any question on simplifying square roots, or does anybody want me to make up another one? Okay with that? Okay. All right, so the last formula we're going to look at is the midpoint formula. This one does not have as much to do with a triangle, but usually when we study distance formula, we do midpoint with it. That's kind of why we're doing it. Okay. It still starts out with the same information. Okay, you need to be given point A and a point B. The goal this time, though, is not to figure out how far apart they are, but to figure out where is the halfway point between the two of them. Now let's forget that it's about a coordinate for a minute. Let's just pretend you had two grades. Like you had a 70 and you had a 90. And those were your two grades. Those are the only two grades for the whole term, 70, 90. And I want to give you a grade on your report card. To give you a grade, I need to find what's exactly in the middle of a 70 and a 90. What do you call that when you have two numbers and you find out the one that's exactly halfway between the two?
The average.
It's the average. If you have two grades, how do you find the average of the two? It's two steps. Yep.
You add them together and then you divide them by the number.
Right. And if we had two grades we were averaging, we'd add them up and divide by two. That's exactly what the midpoint formula is. It's an average and then another average. You add up the two x's and divide by 2, and that gives you what's exactly halfway between the two x's. And then separately, you add up the y's and divide by 2, and that gives you what's halfway between the y's. So another way to think of the midpoint formula, it's the average of the x's, comma, average of the y's. That's all it is. It's two averages. Okay, one thing that can be a little tricky with it is some people mix this up with the distance formula. This one has an x1 plus an x2. This one has minus with the x's. So you got to remember that these you're subtracting, but here you're adding. Okay, and since you can make a reference sheet, I would just put those two formulas on your reference sheet. Okay, so no real triangle with this formula, it's just finding what's an average, that's all it is. Does everybody have the midpoint formula? This formula also does not involve any square roots, so that having to simplify roots like in the last one, that's not going to happen in this one. Worst thing that can happen is you divide a number by 2 and you end up with a decimal that's a 0.5. Okay, that's the only thing that can happen. Okay, so let's find the midpoint between those 2 points. So we've got 3, 4 and 7, 13. All right. So what do you think I'm going to do first here? Just like I did when I did the distance formula. It's the same first step. Yep.
Label your x's and y's.
Yeah. Again, if it's just so you don't confuse yourself, label all the x's and y's. So let's start with the 3. The 3 could be labeled as
X1 or x2.
x1 or x2. You can pick. Okay, but once we make that decision, then everything else is automatic. So what do we want to label the 3 as? X1? Okay. So now there are no more choices. Okay. The 4 has to be Y1. The 7?
X2.
Yep, make that X2. And the 13? Y2. Okay, so let's fill everything in, see if I can get the formula up there at the same time. And we're going to fill everything in. Start with all that. So Lewis, when I fill in, what's going to be on the left side of the plus sign in my first fraction?
3.
Let's see, we're going to go with x1. x1 is 3. Perfect. Okay. How about Jada, what's going to be on the right side of my plus sign in the first fraction?
4.
So we want to make sure that we keep all the x's together in the same numerator. 7. Yep. 3 plus 7. Okay. How about in my numerator for my second fraction? What's going to be both numbers that are in the top? Yeah.
4 and 13.
4 and 13. All right. So let's add them up. We're going to get 10 over 2, we'll simplify that. That's the average of the x's. 17 over 2 is the average of the y's. Now, the second number you could leave as 17 over 2. That's fine. Don't leave the first number as 10 over 2. What does 10 over 2 simplify? Yeah, 5. And 17 over 2, again, leave it like that, or I guess if you were going to graph the midpoint, you might want a decimal, which would be how much? It would be 8.5. All right, let's see if that looks right. Graph my 2 points. So I got 3, 4. So I got 1, 2, 3, 1, 2, 3, 4. I'm gonna have to estimate one of them because 13 goes off my graph. 7, 13. So 1, 2, 3, 4, 5, 6, 7. That's 10. And now I need 3 more units. So what I'll do to get it pretty accurate, is I'll just measure 3 units, stack that on the end of 10, put my dot right there. So that's B. Now we're going to find the distance between A and B. Or not the distance, sorry, the midpoint. It should be 5, 8.5. Right, let's check it. So we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8.5. Okay, that's where we think the midpoint is. The way I can check it, I can try to draw a straight line there. Let's draw a straight line there. Now, let me take those two, line them up, and see if they're the same length. Okay, if they look like they're the same length, then I know that that's the midpoint, just roughly by eye. Okay, that looks pretty good. All right, any questions on that? All right, so that's the only section that we do in chapter 1 in this new book we're using now. Okay, so tomorrow we start chapter 2, which gets into angles. How do we measure angles? Degrees, and there's another way besides degrees, and I'll show you what that is tomorrow. All right. So not every lesson in trig ends super early. This one ends a little bit early. But those are the questions from the book, 15 to 21 odd, 39 to 43 odd. And I want you to simplify those 4 square roots. Let's see. Okay, and by simplify, I don't mean I want a decimal. I want you to reduce it like we did. Okay, so you still have, still got about 25, 30 minutes. So please use that time to try to work on it. If you finish it with the time we have left, just show me. I'll check it off, and then we won't have any homework tonight.